Alright. A beam 8-meter long has its supports 5-meter apart such that the beam overhangs on right side. A uniformly distributed load of 12 kilonewton per meter is applied on its entire length, along with a point load of 50 kilonewton at the overhanging end. Draw the SFD and BMD for the beam and also find the location of point of contrafluxure. So we have studied about uh, simply supported beams. We have also studied about the cantilever beams. A combination of these two is the overhanging beams. Right? We discussed this in the first lecture in this unit when we discussed about types of beams. Right? So I have drawn a picture here. So I have two supports. This is beam ABC is the entire beam, complete beam, and I have two supports which are 5-meter apart. Right, 8-meter long beam has its supports 5-meter apart such that beam overhangs on the right side, right? So on the right side of the beam it is overhanging like this, and on the entire length of the beam I have a UDL of 12 kilonewton. So I have shown a UDL here for of 12 kilonewton per meter for the complete length, and also there is a point load of 50 kilonewton at the overhanging end. This is the overhanging end. Draw the SFD and BMD for this and also find the point of contrafluxure. We'll try to understand what is point of contrafluxure little later. First, let us try to solve. Okay. Now, like any other SFD BMD problem, first thing we need to do is find the reactions at supports A and B, right? So I need to find this value. So for this, I have two conditions. Sum of all the forces is equal to 0. Sum of all the moment is equal to 0. Right? Now, taking the first condition, sum of all forces on beam is equal to 0. What are the forces that are there on this? Now, I will take the upward force. So that is RA plus RB. These are the two upward force, and there are two downward force minus 50 kilonewton, that is here, and this UDL is also a force, and that magnitude is 12 kilonewton per meter. So 12 into 8 is the total force of this UDL, which is acting in the downward direction, right? So I have taken upward positive, downward negative, and this should be equal to 0, right? Or RA plus RB is equal to 50 plus 12 into 8, so that is 146 kilo Newton. That is the total force which is acting on the beam. Now I will take the second condition, sum of all moments on beam is equal to 0. Sigma m is equal to 0. Now I will take the bending moment about section A. So before that, let me draw the sign convention. So the sign convention that I am going to follow, I do like this. First make a box with 4 cells. Then I write here, this is left side, this is right side, this is clockwise, and this is counterclockwise, right? So always left side clockwise is taken as positive. So the diagonally opposite to that is also positive. This will be negative, and this will be negative. Okay. Now again, let us come back to this numerical. Now I am taking moment about A. So if you're taking moment about A, start from the opposite side. So let us start from point C. So at point C, I have 50 kilonewton force acting downwards, right? So downward force, it is making a clockwise moment on the right side clockwise. So that is negative. So minus 50 into perpendicular distance is 5 plus 3, that is 8 meters. Then I have uh, the force due to UDL here. Now this is a single UDL. The intensity is same, 12 kilonewton per meter for the entire length, right? And this can be assumed as a point load at the center of the UDL. Now the intensity is 12 kilonewton per meter, and the total length is 8 meter, and this is also acting downwards. So the sign will be negative for this also. Minus 12 into 8, and 8 is the total length. It is acting at the midpoint here. So that will be 8 by 2, and that is 4 meter. This is the downward force. Then I have the reaction at B, which is in upward. So right side upward force. So this is making a counterclockwise movement. Right side counterclockwise is positive, plus RB into the distance between A and B is 5 meter. RB into 5, and this should be equal to C. Now if you solve this, you will get RB. RB is equal to, let's do this. So these two are negative, so this will come on the other side as positive. So 50 into 8 plus 12 into, sorry, 50 into 8 plus 12 into 8 into 4. This is 748, and divide this by 5. So 156.8 is the reaction at B. 156.8 kilo Newton. Right? This is the force in the upward direction, because I have got this.
Sir,
Yes.
hello, sir.
Yes. Yes.
Sir, RA plus RB is equals to 146, sir. RB is only 156 point how?
Yeah. You please allow me to tell that. Okay. Now RB is 156.8 kilonewton. Now you put this value of RB in this expression. Okay. So from this I get RA is equal to 156 minus 156.8. So 146 minus 156.8 is minus 10.8. This is minus 10.8 kilo Newton. Now what does this mean? This negative sign indicates the direction I have assumed is not correct for RA. RA is downwards, not upward. Did that answer your question?
So, so I calculate my RB is coming is 89.6 kilonewton.
Really? You did something else or was
Yes.
something what I did here?
So I did correct.
50 into
So I also do 50 into 8 plus and 12 into 4 plus 12 into 4.
8 into 4. 12 into 8 into 4.
So 4 होगा ना?
12 into 8 into 4. See,
So
12,
why?
12 kilonewton per meter into 8 meter.
Yes.
So it becomes 12 into 8 kilonewton हो जाएगा, and that is acting at a distance of 4 meters somewhere here, right? So that
Okay.
force into this distance.
Okay.
Got it?
Okay, sir.
Yeah. So you
Yes, sir.
did this only. So this by 5, it is correct. Okay. So the reaction what I have taken in the upward direction is incorrect. So I have to change the direction, right? So I'll just mention that here. This negative sign of RA indicates it is in downward direction. Okay, it is acting in downward direction. So I will show that again. I'll show it in different color. Okay, so this is my RA which is acting in downward direction. So I will just write that there. RA is equal to, now I'm showing the direction here, so I don't have to write the negative sign. I will just write 10.8 kilo. Is this okay? Now we'll start with our shear force diagram. Now to draw the shear force diagram, we'll start with this end. Like I have always explained, start with this end and then we proceed as this changes. Right? Now, first of all, I will draw a zero SFD line. I'll draw a horizontal line basically like this. Okay. Now at point A, you start with RA. In all our previous numerical, yesterday also we did some numerical, wherever you have this force in the upward direction, we took like this. Now since this is negative, it will come in downward direction, right? So first I'll start with point A. Now initially the shear force on the left side of point A is 0, right? And it increases from 0 to minus 10.8. Let us say this is 10.8. So I'll just write that this is 0 and this is 10.8 kilo Newton. All right. So it has come down now. Now between A and B, I do not have any point load. Okay, so I do not have any point load. It is just uniformly distributed load, UDL, which is varying like this. Now what I have to do is the shear force at this point I will have to calculate, that is point B, right? So how to find that? Use my calculator. Yeah. Now in this calc, what you have to do is first type minus 10.8. So I have minus 10.8. I am at minus 10.8. Now from this I have to again subtract this much shear force. 12 into 5. At this point it will be 12 into 5 kilonewton. So minus 12 into 5. So this will be minus 70.8 kilonewton. Okay. So let me just mark that point. Let us say this is 70.8 minus 70.8. So this is minus 70.8. So I will just connect these 2 points. Shear force variation for a UDL is always a inclined line like this, straight line. So it varies like this. At point B, I have reaction RB, which is vertically upward, which I have taken it as positive. Now, what is the value of that? It is 156.8, correct? Now, I will add plus 156.8. So, it is 86 kilonewton. So, I will draw another line like this. Now let us say this is 86 kilonewton force, shear force. Now between B and C there are no point loads, and again there is UDL. So from this I have to subtract the total force of this UDL. How much is that force? 12 into this length, that is 3 meter. So I have 86 here. Better write it down. This is 86 kilonewton force. And how much was this? 70 point something, right? 86 minus 56.8 minus 70.8. So I'll just write this 70.8. Since it is on the negative side, it indicates minus kilo. You don't have to explicitly write minus here. Here I can write it as minus like this. Okay. Now I am at 86. Now from this I have to subtract this much shear force, which is proportionate to the UDL. So that is 12 kilonewton per meter into 3 meter length. So that will be 50. So let us say 50 is somewhere here. So this point is 50 kilonewton. Now at this point I have a vertically downward force which is 50 kilonewton, which is acting down in this direction. So I will draw a line like this. Now this completes my SFT. Now this is 0 kilonewton and this is plus or positive shear force and this is negative. Actually it became little out of proportion because this is 86 and this is 70.8. This should have been little smaller. It's okay, right? Let us not spend much time on this. Any questions so far? Great. Now let us start with BMD. Now to draw the bending moment diagram, I will again draw a zero bending moment line. Now let us calculate the bending moment at various points. Now the main points we have is A, B and C. Now since the shear force is changing direction only at the support, it is not changing direction anywhere else. Suddenly it is not changing from positive to negative, right? So we may not have the maximum bending moment condition for this particular case, right? So let us try to find the bending moment. The bending moment at this end A and this end C will be equal to 0 because they are the free ends, right? So the bending moment is always 0 for such points. So I can directly write that BMA is equal to BM, what was that point? C, right? Is equal to 0. Reason: support at A and free end at C. Right? Whenever you have a support or free end, you will have the bending moment equal to 0 at those 2 points. Now you will have to calculate the bending moment at other point, that is B. Right? Now how to find the bending moment at B? BM at B. Now BM at B, um, you can calculate using left side or right side. So I'm taking right side because it is small force here. So here I have 50 kilonewton force which is acting downwards, and this is making a um, clockwise moment, right? So on the right side clockwise, so it is negative, both will be negative. So this is minus 50 into the perpendicular distance between B is 3. Then you have this UDL that is also downward, so minus 12 into the length is 3, that is the total force, and that is acting at the midpoint, so it is 3 by 2. 3 into 3 by 2. So this will be 50 into 3 plus 12 into, this is a 9 by 2. 204. This is minus 204 kilonewton meter. Okay. So this is the bending moment at B, considering the right hand side. Now let me check it from the left hand side also. If I get the same, then there is no problem. Then the entire BMD will be negative. So BM at B LHS is equal to, now I have reaction RA which is pointing downwards like this. So because of this, it is making a counterclockwise couple or moment on the left side. So it is negative. Left side counterclockwise is negative, minus 10.8 into the distance is 5 meter. From A to B it is 5 meter. Again minus because this force is also downwards. So it is 12 into, instead of 3 here, it will be 5. 5 into 5 by 2. So this will be again negative 10.8 into 5 minus 12 into 25 by 2 minus 96 kilonewton meter, right? So that means the bending moment is changing at uh, the support B, right? So let us try to draw the BMD for this. Mm, I I'll move this little upwards because the bending moment is negative at all the point. So the BMD will be on the downward side only. So I'm just moving this zero line above. Now I have BMA and BMC as 0. This is 0 and here also it is 0. At B, that is this support, here I have 2 points. One is minus 204 and one is minus 96, right? So let me just mark these 2 points. Right hand side it is minus 204, so it will be like this and like this. Okay, so I will have to, sorry, draw a parabolic curve between these 2 points. Okay, so this is a, I'll assume that this is a parabolic curve, and between this point and this point you'll have another parabolic curve and a straight line here. Okay, and just name the points, show the values. This is 0, this is 0, here this is 96 kilonewton meter, and this value is 204 kilonewton meter, and this is negative bending moment. Okay, so this is the solution to this problem. Just write this as BMD, this as SFD, and all this stuff. Any question?